Finding the LCM using prime factorisation. If we have to find the LCM of 12 and 32, we know we can list some multiples and find the smallest value common to both numbers. So multiples of 12, 12, 24, 36, 48, 60, 72, 84, 96, 108. And for 32, 32, 64 and 96. The LCM is 96. Now I'm going to use these same numbers to show you how to find the LCM using prime factorisation. And the great thing about this method is it works for any number of any size. First, we do the prime factorisation of each of the numbers. Primes in red and composite numbers in blue. 12 is from 2 times 6. 6 is from 2 times 3. Circle the primes. 32. 4 times 8 is 32. 4 is from 2 times 2. 8 is from 2 times 4 and 4 is from 2 times 2. Circle the primes. Next, we make a quick table of the prime factors. Using columns, we match the like factors. Leave a space where there's no match. 32 has the prime factor 2 5 times. Write them in. 12 has the prime factor 2 twice. I leave spaces and then put its remaining prime factor 3. I put a line under the prime factors to help my thinking. Finally, we find the prime factors of the LCM. We use one factor from every column, and if there's a vertical pair, we only take one of those factors. The LCM of these numbers is the product of these factors. 2 times 2 times 2 times 2 times 2 times 3. Work it out. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. 32 times 3, well, 3 times 2 is 6, and 3 times 3 is 9, so the LCM of 12 and 32 is 96. And we know this is right because we already found the LCM using the multiple listing method. Now we know the method works, let's try a slightly more tricky pair, 28 and 35. First, find the prime factors of each number. 28 is from 4 times 7. 4 is from 2 times 2. Circle the primes. 35 is from 5 times 7, both prime. Next, we do the prime factors table. Match factors vertically, leave a space if there's no match. 28 is 2 times 2 times 7. 35 is 5 times 7. Now we get the prime factors of the LCM. 2 times 2 times 5 times 7. Finally, work out the value of the LCM. 2 times 2 is 4, times 5 is 20, times 7 is 140. You can see when you are given even bigger numbers, using the prime factorisation method is going to be very helpful. Now here's a challenge for you. Using the method I just showed you, find the LCM of 15, 32 and 66. You can do it. When you've done this for yourself, click the link here to check my solution video and see if we got the same answer. And remember, the more practice you do, the stronger your math muscles become. Using prime factorisation, find the LCM of 15, 32 and 66. I'm going to walk you through it. Have your finished work in front of you so you can check your steps with me. Pause the film and do it now if you haven't already finished. Here's my process. First, we find the prime factorisation of each of the numbers. 15 is from 3 times 5, both prime. 32 is from 4 times 8. 4 is from 2 times 2. 8 is from 2 times 4, and 4 is from 2 times 2. Circle of primes. 66 is from 11 times 6. 6 is from 2 times 3. Circle of primes, as you've probably been doing already in school. Now set out a prime factors table and put the like factors in vertical columns. Leave a space where there's no match. When I set out this table, I have to order the numbers somehow. So I pick the number which has the highest occurrence of the prime factor 2, because it generally ends up looking neater. 32 is 2 to the power 5. It has the prime factor 2 5 times. 15 has the prime factors 3 and 5. 66 has the prime factors 2, 3 and 11. Notice how only factors that match are in vertical columns. Everything else is in its own column. All the prime factors are listed in the table now, so next I find the prime factors of our LCM. One factor from each column. 2 times 2 times 2 times 2 times 2 times 3 times 5 times 11. And now we work out the value of our LCM as shown by the prime factors we have here. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 3 is 96, times 5... Okay, I need a quick note to help me with this one. 5 6s are 30, 5 9s are 45, add in the remaining 3, 48, 96 times 5 is 480. And now 480 times 11. Okay, another quick scribble. 11 times 0 is 0, 11 times 8 is 88, 11 times 4 is 44, add in the 8, that's 52, 5,280. There is the LCM of 15, 32 and 66, 5,280. Did you get that too? If not, please check your math against mine to find out where you made a mistake. There are online LCM calculators which you can use to check your work after you've done the calculations. What can I say? It's much quicker than listing multiples to check your own work. Any guess how long that calculation would have taken if we had tried to use the listing the multiples method? Without the prime factorisation approach, I would have probably given up after about 15 minutes. How about you? If you'd like a really tricky LCM challenge, click on this link. For this, you'll need to do prime factorisation through short division, so click it and come on over if you're up for the challenge. If this video helped you, please click the thumbs up. Thanks! Here's a really tricky challenge in LCM. In this video, we'll find the LCM of these three numbers. I'll use the prime factorisation method to get the LCM. I'll use a factor tree and short division. Hit pause now and give this a go for yourself. When you're ready, click play to see my solution. Start with the prime factors of 81. 81 comes from 9 times 9. 9 is from 3 times 3. Those are the primes, and it's the same for the other 9. Note down the prime factors in a quick table. And now I can clear the working area off. 231 is next. This is not in any multiplication table I know, so a factor tree is no use here. I'm going to use short division to quickly extract the primes. I can apply the rule of divisibility for 3. When I add these digits, 2 plus 3 plus 1, I get 6, so I know 3 is a factor. 231 divided by 3. 3's into 23, 7 3's are 21, remainder 2. 3's into 21, 7 3's are 21. 77. I'll divide by 7. 11 sevens are 77. 11 is prime. 11's into 11, 1. Write in the prime factors of 231. 3 times 7 times 11. And now for the big one, 3,465. Obviously, this calls for the short division route to extract the primes. Our number ends in 5, so we can instantly tell that 5 is a factor. So start off by dividing by 5. 5's into 34, 6 5's are 30, remainder 4. 5's into 46, 9 5's are 45, remainder 1. 5's into 15, 3 5's are 15. 693. I can tell immediately that this is divisible by 3 because each individual digit is divisible by 3. No need to add the digits this time, just apply your common sense. 3's into 6, 2 3's are 6, 3's into 9, 3 3's are 9, 3's into 3, 1. 231. What a coincidence! We've just done 231. We know its factors already. Let's save some time. I can write in the prime factors that I found through short division so far, then repeat the factors of 231. It isn't cheating since I did the work once already. So we've got 3 times 5, and then from 231, 3 times 7 times 11. So the factors of our mystery LCM are 3 times 3 times 3 times 3 times 5 times 7 times 11. And now we use those factors to find our mystery LCM. And for speed, like you'll be doing, I'll use a calculator to get that LCM. 3 times 3 times 3 times 3 times 5 times 7 times 11. The LCM is 31,185. If you're like me, after you've done this on paper, you will check your own calculations with one of the handy-dandy LCM finders that people have so generously put up online. And you'll find that they come out with the same answer as I just got. The key thing to realise about LCM calculations is there is more than one method we can use. Sometimes we can simply use our times table knowledge and list multiples. Sometimes we need to use the prime factorisation method. We could do a factor tree if we know 2 of the multiples, or if it's a really big number, we're going to have to use short division to pull out those prime factors. Each method has its own time when it is best used. As a mathematician, you decide on the quickest method for each question, and you use that, and practice till you are confident.